equivalent resistance and Kirchhoff's law or Kirchhoff's rule. So now let's start from the first one, which is the equivalent resistance, R equivalent. For the first case, it's better to start from series connection. Series connection, just like this one resistance connected with the other. This is an example of series connection. Let's say we have a DC. This is a DC. Consider this is R1, R2, R3, R4. So in a series connection, the equivalent resistance, which is the total resistance, is equal to the sum of the individual R1 plus R2 plus R3 plus R4 is the voltage. Okay, so the other thing that we need to consider in a series connection, the previous series connection, we have, as we have seen, resistance 1, resistance 2, resistance 3, and resistance 4. And then the voltage. So this is R1, R2, R3, and R4. The equivalent resistance, R equivalent is equal to simply R1 plus R2 plus R3 plus R4. So if you have a very large number of resistance, in general, the general equation R equivalent is equal to R1 plus R2 plus it carries on, then finally the sum of Ri, where I starts from 1 up to n number of resistance. And the other thing that we need to see here is the total current. Total is always equal to I want the current on resistance 1, and it's equal to the current on resistance 2, I2, and it's also equal to the current in resistance 3, which is I3, is equal to the current in resistance 4, I4. So total current is the same as the current in resistance 1, in resistance 2, in resistance 3, and resistance 4. And regarding that voltage, total voltage is always equal to the sum of the individual, which is V1 plus V2 plus V3 plus V4, which means the voltage drop in resistance 1, voltage drop in resistance 2, voltage drop in resistance 3, voltage drop in resistance 4. So when you add them together, you get the total voltage, or the general equation for total voltage is VI, where I starts from 1 up to n value. So if you have n number of resistor, 100 resistor or 50 resistor, so you have to add the voltage drop in each resistor, and finally you get the total voltage. This is what you have in series connection. Second one, number 2, which is equivalent resistance in case of parallel connection. Are equivalent in case of parallel connection. For example, let's have voltage DC source. Let's have resistance 1, R1, another resistance which is resistance 2, and then third resistance R3. So there R1 is connected in parallel with R2 and in parallel with R3. Therefore, if you are asked to find the total resistance, R equivalent is equal to 1 over R1 plus 1 over R2 plus 1 over R3. This is how you get the total resistance. But if you have a very large number of resistors, so R equivalent, 1 over R equivalent is equal to 1 over R1 plus 1 over R2 plus n number of resistors. Therefore, this is equal to the summation where I start from 1 up to n number of resistors, 1 over Ri. The voltage, total voltage, the voltage total is equal to V1 is equal to V2 is equal to V3. The voltage in each resistor, first resistor R1, the second resistor R2, the third resistor R3, they have equal voltage. This is the source. So this voltage the voltage drop in R1 is equal to R2 is equal to R3. Therefore, the total voltage, this voltage is equal to R1, voltage drop in R1 and voltage drop in R2 and voltage drop in R3. The total current is equal to, in parallel connection, is equal to I1 with the current drop in the first resistor, the current drop in the second resistor, let's say I2 plus I3. So in general, in parallel connection, the total current is equal to I1 plus I2 plus n number of connection may be there, so which is equal to resistance from 1 up to n number of resistance. I will be the total current that passes through each okay. The other one is Kirchhoff's circuit rule. Rule. So we start from the first one, which is Kirchhoff's first rule, and the other name of Kirchhoff's first rule is called junction rule. Okay, it says that the incoming current toward the junction is equal to the outgoing current, or the summation of I in toward the junction is equal to the summation of I out from the junction. Consider this is a junction. The first incoming current, let's say this is I1. The second incoming current, let's say this is I2. We have the outgoing current, let's say this is I3. Another outgoing current, let's say this is I4. Another outgoing current, let's say this is I5. So the incoming current is equal to outgoing current. Therefore, for this one, I1, summation of I1, the incoming current, plus I2 towards this junction, I2 is equal to the outgoing current, which is I3 plus I4 plus I5. These are the incoming current and these are the outgoing current. Let's have a simple example. Let's say the incoming currents are this one, first current, the second one is this, and this is a junction. Another current is going in this direction. So we may have number of currents. Let's say this is 2 ampere, and this one is 3 ampere, and this is 5 ampere, and this one is 6 ampere, and this is 2 ampere again, and let's say this is unknown. So the question is, find the unknown current. The unknown current on this resistor. You may call it this is R1, R2, R3, R4, R5, R6, whatever you want. Therefore, the question is, the incoming current should be equal to the outgoing current. So the incoming currents are 3 ampere plus another incoming current towards the junction, which is 2 ampere, plus the other incoming current, which is 5 ampere, plus another incoming currents are this one, which is represented by I, which is equal to the outgoing current that leaves this junction. The first one is 6 ampere plus second one is 2 ampere. Now let's add these two together. 5 plus 3, which is 8, 8 plus 2, which is 10 ampere, plus I, which is equal to 6 plus 2, which is 8 ampere. So in this case, I is equal to 8 ampere minus 10 ampere. I is equal to minus 2 ampere. Here you can understand that this minus sign indicates that this is not the correct direction of current. The correct direction is this way, not towards the junction, but it's away from the junction. That is the indication of the minus sign, but the current is the same. The current is 2 ampere. Kirchhoff's second rule, or the other name of Kirchhoff's second rule, is slope rule, or Kirchhoff's voltage law. So this is the sum of the voltage across the loop is equal to 0. Like for example, let's say we have this one DC source, and let's say this is a resistance and the current is going in this direction. Now it's connected like this. Consider a loop, either clockwise or counterclockwise. So based on this loop, this is the voltage V. The sum of the voltage across this loop is equal to 0, according to Kirchhoff's second loop rule. That means V plus V plus this is minus I times R is equal to 0. Consider this is 20 volts. Let's say this is 2 ampere. So if you are asked to find the current that passes through this resistor, you have to use the Kirchhoff's second rule or loop rule. That means plus 20 volt minus I 2 ampere, no, 2 ohm. Let's say this is 2 ohm resistance, 2 ohm multiplied by current, which is equal to 0. So this will be equal to 20 volt, which is equal to, when it takes this to the right side, it becomes positive. 2 ohm times current divided by 2 ohm divided by 2 ohm, and current will be equal to 20 divided by 2, which is 10 ampere. So 10 ampere passes through this resistor. Okay. So in general, you can follow the following procedure for find if you have a certain resistor. If the current is going upward, this is the direction of current, this is the resistance. If you have a loop direction like this, if this is the loop direction, if the current direction and loop direction are the same, so you need to use minus I times R. But if you have resistor like this, resistance, and the current direction is downward instead of upward, then if the loop direction is upward, there you have to use plus I times R. And the other one, if you have current direction which is upward, the same as this one, resistance R, and this is the current direction. If the loop is downward, so in this case, if it's similar to this one, you have to use plus I times R. And the same thing, if you have the current direction like downward for this one, but this is loop is upward, if this loop is downward, then you need to use minus I times R. This is the current and this one is the resistance. But in case of voltage, let's say we have a DC source, and let's say this is minus and it's plus. If the loop direction is this way, if this is the direction of the loop, so you need to use a minus V value. If this 10 volts, minus 10 volt, 20 volt, minus 20 volts. But if the loop is, consider this is a plus, minus, this is a minus sign. If the loop is upward in this direction, so when it goes from minus to plus, so you have to use plus V value. If this is 10 volt, you have to use plus V value, plus 10 volts. Example. Let's take example. Consider this is the source, this is a plus sign, this is minus sign. Let's say this is 10 volts. We have a resistor which is, let's say this is 2 ohm, another resistor, let's say this is 3 ohm. They are connected in series. So now let's apply Kirchhoff's second rule or loop rule. So consider this direction. Now the conventional current flows in this one. Let's say this is current I1. I1 goes in this direction, but we don't know the values of I1. And series connection is the current is the same. Therefore, in this case, the loop goes from minus to plus, so we have to use plus 10 volts. Then the direction of the loop and the current are the same, so minus I1 times 2, 2 times I1. And the loop direction is downward, and this is downward, so I have to use minus, which is 3 times I1. Current is the same, is equal to 0. So according to Kirchhoff's voltage law or loop rule, so the sum of the voltage across the loop is equal to 0. This voltage, the second loop here, and the third one is equal to 0. Now let's calculate this one. Take this to the right side, it becomes positive 10 volt, which is equal to 2I1 plus 3I1, which is equal to 5I1. Therefore 10 volt divided by 5, which is ohm, is equal to I1. So I1 is equal to 2 ampere. So I1 is equal to 2 ampere. So this you can solve any type of question.